Alright, welcome to the StudFinder Rhino overview video. I'm Adam with Stud.io. I'm the Chief Product Officer here and really excited to show off some of the features we have and get you started using StudFinder in Rhino. So let's get into it. Alright, if we look quickly at Rhino, I've launched Rhino after installing StudFinder. What you may notice on the right hand side is this new StudFinder tab or StudFinder panel. If that is not showing up for you, you might not have it activated. It would be over here. You can activate it by right-clicking on this panel and finding StudFinder and turning it on. The first step to using StudFinder, of course, is to log in using your Stud.io credentials. So once you log in, you'll get a login successful window. Make sure that you hit OK. Sometimes that hides behind things. You want to make sure that that gets cleared in order to get to the next step. Before we get started, I want to go through the StudFinder panel that now shows up once you've logged in. We have a File tab which allows you to import and export studs. This is where you're going to export fabrication files. A Project Browser, which is going to show you all the structures in your project at any point in time. The Object Properties panel, which is going to show you object properties based on the type of object, StudFinder object you're selecting. It could be a stud, it could be an assembly, it could be a structure or a region. Assets, this is where you can manage all of your assets. We're not going to get into this particular section today, just because it's a little more advanced than we need to get started. And you have your account settings. So if you want to change the way that you're viewing color of members, you can kind of change that here and log in and log out. So let's get into it. The first thing to know about StudFinder is that all of our commands begin with the letters SF. So if you start to type SF up here in the command line, you'll see a bunch of commands pop up. These are going to be the commands that we're going to go through today and go through and make sure that all of this is understanding, kind of you can get started using these. So the first command we're going to get started with is SF create structure. So select two lines and draw two lines and select those and create SF create structure, and that will turn those lines into members. So we can name our structure, so test structure, and the default member type is great for us today. Before we go any further, let's look at our project panel and understand that now this new structure shows up. It has one frame in it and two members. So we have member 0 and we have member 1, obviously. And if we look at the way to color this, we could color this by structure, which is going to be this nice blue color. I'm going to change the color of the frame to green. We can color by assembly, which is the next level, which is this A frame, which is green. Or we could color by member as well. So this 0 member is purple, this 1 member is pink, or is blue. Other ways that you can color is by member type or by uniform. Member type is going to look the same. These are both the same member type for right now. And uniform is just going to keep them all a similar gray. So this is going to be the way I'm going to look at them for right now, as colored by maybe structure. After you've created your first structure in this project tab, the first thing we might want to do is add members. So SF add member is how we're going to do that. We can click on a member to add that structure to. So SF add member, could do that again. It asks you to select a member of the structure to add to. So we click any member in our scene because we only have one structure, and then a start and an end point for that member. So if we keep doing that, you can see how we can add a bunch of members in our scene. Another way to add members is to simply just copy things. So you can use the copy command. This is a built-in Rhino command, and you can copy and paste. You could use the gumball to holding Alt and copy. Really, any way that you can create a copy of something, of a curve, particularly in Rhino, you can do for members. So array, copy, paste, that sort of thing. All that should work. The other thing that you may want to do right after you add members might be to delete members. The first way to do that we'll go through is SF delete members. You can select a member and hit enter and it will delete. You can also just select a member and type delete on your keyboard. That will work as well. And then there are additional commands here as well. So if I copy this up, you'll see that now I have one structure with 2 frames. We can SF delete assembly. Select a member that is a part of the assembly that you want to delete, and it will remove it. And there's also SF delete structures. So that would mean pick a member that is a part of any structure, and it will delete the whole structure. Similarly, all these things can be activated from this side panel. So if you want to select a particular member or delete a particular member or assembly, you can select and delete from the side panel by clicking on an object and then right-clicking and doing it that way. So I will delete all that, and let's start with something brand new. And let's get into modifying members. There's multiple ways to modify members. First way we're going to go through is by the side panel. So let's quickly just color this by member. Look at our project browser, and let's say we want to modify this blue stud. One way to get to it is to the Modify in the Object Properties tab is to select on that member and click on the Object Properties tab. Another way is to right-click and hit Edit. That will get you there as well. This Properties tab allows you to name or modify a couple of properties on each member. Could be update the name. You can update the color. And if I bring that over from my other screen, we can make this stud red. We could change the member type if we want. We can change the priority, and we can change the normal. So the normal, think of the normal as a vector that goes from its axes to the open side of the stud. So right now this stud is kind of facing the positive X direction. So let's say we wanted to flip this to go the opposite X direction. And anytime you're modifying properties in this right-hand panel, you're modifying one stud, one frame, one structure at a time, and it only updates once you hit update. So I click update. You'll see now that the name of that stud says test, that this stud turned red, and it went faced to the negative X direction because that's the normal that I told it to do. If you do want to modify multiple members, we have a command, SF modify members. This allows you to modify multiple members. You can change its member type, its priority, or its normal. So let's say right now kind of all these studs are generally facing kind of negative X or negative Y. Let's say we want to make them face kind of positive X or positive Y. We can do SF modify members. Click on its normal, and then it says it's asking for a start point. So think of this as the start of a vector, and there will be an end point as well. So start, end, hit enter, and those now will face positive X and positive Y, generally kind of facing up and to the right of my screen. So that's a handy way to modify multiple members all at one time. So real quick, just show you again. You can change members as well. So if you want this to be a 4-inch stud, you can go and do that be a 4-inch stud, and that will, of course, update any other members due to our solver running in the background that is connected to it. Other ways to modify members, you can take this member, and if you rotate it, you could rotate it into a different way. So this is a new type of connection that got kind of created by our solver because we kind of rotated its normal to face up, positive Z, which is kind of the blue vector here. It forced this other stud to kind of face negative Z, and our connection updates as well. You can also then use SF flip member normal. So this is a quick command used to just take this stud and flip it to the opposite direction, so 180 degrees from what it does. So If you see, if I do that on this one, SF flip member normal, it'll flip also the one that's connected due to that solver. It's going to force that to be the opposite direction. So we can flip that one, we could flip this one, and they'll both react. So that's SF flip member normal. Real quick, let me get set up for a couple other things. If we backtrack just a little bit, other ways that you can modify members, like if you need to extend them, trim them, things like that. Anything that, again, that you can do to a curve, you can do to a member. So if you want to trim any of these studs that are out past this member, you can do that. They turn black for a moment, saying that, hey, these have been modified, and once you exit the command, they kind of update and then turn back to being whatever the color they were. If you need to fillet two studs, you can kind of do that all at one time. Similarly, you could also extend two studs and do that. So pretty easy way to modify members, really trim and clean things up quickly. And then the last thing probably you might want to do manually would be to add operations to something, to a member. So of course, any member that is involved in a connection, those connection operations, so what you need to actually connect this stud to that stud with alignment, so lip cutting, notching, swaging of this other stud, dimpling of both of those are going to be connection operations, and those will get generated automatically by our solver. But you might want to add additional operations to a stud, like a web punch to join two studs together. You might want to add a service hole so that MEP or blocking can fit through. So that can be done in a couple different ways. If we look at SF add operation, there's three commands I want to go through. SF add operation, which is going to be one stud. SF add operation on curves, which is going to be you draw a curve and uses that curve to add operations wherever it intersects a stud. And then add operations on a plane. So if you think about a plane that slices through your whole structure, it would add operations on that plane. So let's start with SF add operation. It asks you what member to add that operation to. You click on that member. What type of operation do you want to add? Let's add a service hole right there. So pretty self-explanatory. You can add one member, one operation to one member at a time. If by chance you have a curve that, let's say, represents blocking or an MEP penetration through this wall, we could add operations to all of three of these studs at one time using the SF add operations on curves command. Asks you again, select whatever members you want to add operations to. What type of operation? This one, let's add a notch for some reason. And then what curve for the new operation? You can see that then got added where those curves intersect. So this is really handy if you happen to have objects that represent blocking or something like that that you can do. You can add it to multiple objects, multiple members at a time. What's key is that this curve actually does in fact intersect all these member axes. If by chance this curve happens to be up here, it will not necessarily generate these operations. So these operations, once they're generated, they kind of stay there. If I try to SF add operations on curves to these members with this new curve, nothing happens because they don't actually intersect. This is where at planes, I'm going to draw a couple planes real quick. Plane vertical. Let's copy another one over. So if you happen to have multiple operations that you want to add to studs or a structure all at one time, you can do SF add operations on planes, and it will ask for a planar surface to utilize. So what's key when you model this, think of this as an infinite plane that goes forever in all directions on that plane. But this surface does need to be planar. So If you happen to feed a plane or a surface that looks like that, it will not work. So I suggest drawing planes by using the plane command to generate this stuff. So SF add operations on planes. Again, add the members you want to add the operations to. And then what planar surfaces do you want to add for those operations? Let's say we want to add a service hole on these two planes. You hit enter, and now anywhere where those two planes would have intersected, those studs and members, those operations are then created. So that's really exciting way to add operations quickly and efficiently to multiple members. I'm going to add an operation real quick to a stud. So our demonstration here, let's add a service hole right there. All right, so I added a service hole to this one stud. Once you've created operations, we do currently have very limited functionality on what you can do with those operations. Once they're there, it's really best if they just kind of stay there. So think about that in your workflow, do it towards the end, that sort of thing. We are going to be building out a little bit more support for this, but we do have an SF edit operations command. So if you run that, it will ask you to select a member to edit the operations on, and then it will give you this little point for every operation on your curve that you can then drag around. I did tell you that this is a little bit limited. If there's a lot of operations on your member, this kind of behavior gets a little funky as we're developing it right now. But it also doesn't allow you to delete things. So right now that operation is going to stay there and persist basically forever. So if you do happen to need to get rid of that operation, you can delete that stud, kind of copy another one over. For the time being, that's kind of our best solution right now. But stay tuned, we will be introducing features beyond that, for more that later. So that's kind of creating manual structures, kind of building from scratch, basically drawing every single member. If you're interested in getting into more efficiency, kind of generating wall panels or trusses all at one time, we have a feature called regions and recipes that we're really excited about. And we think is going to change the way that people can model framing and can do it really quickly. So if I have, let's just say, a panel extent like this that I drew already, and I want to use regions to kind of fill this out, right? I understand that this is a wall panel that needs studs 16 inches on center. I can use SF create region. It asks for the closed planar polyline as a region boundary. So a couple rules there. This polyline needs to be planar. And it needs to be closed, and it can't have any NURBS curved segments, so straight segments only. Let's limit ourselves to that. Grab the outline of it. We can type a name, so test. Let's put test as the name of the region. Let's add an opening. Here's a quick opening, and there's a recipe here. So we ship a number of recipes out of the box. So this wall 3 5/8, 16 inches on center is good for now. If we hit enter on that, you can see that this built us a little mini panel that is 3 5/8 inch stud, so stud and track. In this, kind of top and bottom of the panel became track. All the studs, kind of vertical studs, became studs, of course, so C-shaped studs. And that quickly generated our stud layout for us. If we look at our project browser on the right hand side, you can now see instead of this being just a structure, this is saying it's a region. So if I click and I hit edit on that, you can see there's a couple more properties in this region that we can modify. The main one that you're going to modify potentially is this recipe. So let's say we made this region and we generated it, and all of a sudden we say we actually only want this to be 4-inch studs that are 24 inches on center because it'll save us a little bit of money. The engineering gave us an option for that. So we can hit update on that, and all of the assembly will update. I'm going to change to by assembly. If you do ever get this error is nothing to be too concerned about. I'm happy to hit it right now because I'm on a development build. It's an authentication error. Just hit OK, log out, and log back in. So. And you'll be able to get right back through that state. So color by assembly. Awesome. So a couple other things to note on regions. These things are really intelligent things until you do something manual to it. So let's just say I need to move this stud 6 inches over because I need some plumbing to go through that panel right there. Once I did that, you can see that this region is no longer a region. It's now a structure. If I edit its properties, I have less properties to add. I can no longer change its recipes. So what you really want to do is use recipes to get really, really close. And then any last minute panel overrides, like let's say you needed to double up a stud or move a stud, you want to do that at the end, right before you go to fabricate. So that is kind of regions. So this SF create region can be done one panel at a time. One panel at a time is still pretty powerful. So real quick, if I want to show off, like let's say I want to build some roof trusses for like a house, SF create region. We can use a truss 48 inches on center region. That will generate that for us. So this is an asymmetrical truss. If by chance we wanted this to be maybe there's not only trusses, but at the end it's just a wall, we could change this to be a load-bearing 6-inch wall at 16 inches on center and quickly change it to that. So lots of options are available to us when we get into this scenario with regions. And you can do some pretty crazy things. So if you happen to make a crazy looking truss that looks like this, you can SF create region. Again, let's truss it at 48 inches on center. It will take that, subdivide it intelligently based on kind of the rules, like this apex and these edges of this kind of ceiling condition that's in there, and make those available for us. So a lot of things will be coming out with regions and trussing and all these kind of common scenarios that you're going to get into soon. So keep an eye on that. If you want to do multiple panels at a time, let's just say 3 panels, planar surface. Let's convert them into surfaces. We can do SF create regions from surfaces. So the rule here, of course, is planar surfaces as region boundaries. So we can collect all 3 at one time. We can apply the same recipe to all those at one time. So let's do 4 inches on center, 24 inches on center, 4-inch stud, and we can run that. If you want to go in and modify this region, you can say that I want actually stud 16 inches on center just for this one panel, and have a truss header over it, and that will update. So using surfaces is going to be a lot faster, allows us to do multiple regions all at one time, and get the power out of regions quickly to frame something. Real quick, I just want to demonstrate how that might be used on a project. So this is a house a client asked us to take a look at and frame with our software, and I want to show you how we can go from a model that had walls. We quickly ran a script that basically put a surface at the center of every wall. So if I get rid of the actual volumes of the wall, you'll see that I've created surfaces for every single wall type. I got 6-inch walls, 3 5/8-inch walls, and roof trusses. Using that SF create region from surfaces, I can select all the 6-inch walls, apply a 6-inch 16 on center recipe to that. It takes a second to generate. You'll get all the framing for that. SF create regions on surface, grab all the 3 5/8-inch walls. Let's generate 24-inch on center spacing for those, because interior walls, maybe they're not load bearing, don't need 16 inches on center. And then same command, select all our roof trusses, change its recipe to trusses with 6 foot on center bays max, and you can see really quickly we've gone from just simple surfaces to fabrication ready regions for all of the framing that we need on this particular project. So it's really important if we can define our framing strategies in recipes, what we can do is go to fabrication much faster. So that recipe long term could handle like what is the header requirements over a door, what are the header requirements over like a big garage door, what are the kind of header requirements, or what are the jam requirements around bigger doors, smaller doors, those sorts of things. All of that, if we can define it in a recipe, will allow us to frame out buildings and things that we need to work on much faster, so we can get to a fully fabrication ready framing model, in a moment's notice. So that was real time, how we can use the power of regions and recipes to really frame out our projects. All right. So that was kind of a quick overview of regions. I suspect in the next couple weeks, month or so, I'll come out with a video on regions, recipes. How do you modify them? How do you think about them? And how do we really kind of get that power into your hands as a user? So we'll bring that out in the next couple weeks, and let's take another look at it. The last thing I want to cover briefly is the export process. So once you've got this stuff modeled, of course, we need to be able to export this to machines. That's the power of StudFinder, is that the machine generation is always there. So at any time, I can go in here and click Export Fabrication Files. Export, a structure or a single frame. Again, this is we only have one structure, one frame in here. So if we hit Export, we come into this export file, we hit Select. Boom, it has exported those assemblies into a folder over here, and has exported them out. So we export CSVs in this particular scenario. This is a Howick machine. The stud and a track get exported into two different members, and then there's two different CSVs or two different machine code files. And then we have a schedule that kind of is a parts list essentially. Other things that you can export is a stud file. So this is like a serialization of everything of where we're at right now. So this is great for exporting and archiving what we did. So at any point in time, you can export and archive that. It will be like a code file that says what exactly did we export. This is also really good for interoperability. So we're about to release StudFinder for Revit. At the time of me recording this video, at least in the beta, that will be able to be brought over to that. This stud file could be imported into Revit quickly, that way modified over there, exported from that place, from Revit. Also could be brought to a web app or kind of future developments down the road. So this .stud file is great for archiving, also great for interoperability. You'll also see you have the ability to import .stud files into a project. So if I'm working on a subset of this project and I need to import another one, or let's say I did all the walls in a different model and now I'm working on roof trusses, in here you could import the walls and have those as a reference. In addition, another thing to export are drawings, of course. We do have a make drawing command. It's a bit in development, so use it a little bit at your own risk. It is currently, since it's in development, make frame drawing, so it doesn't have SF in it, so it's hidden a little bit. Select the stud to export, so select all your studs of your frame that you want to export. This will make a layout in Rhino, as well as a frame drawing that represents that. So this frame drawing kind of is centered on our layout, so if you had a title block or something like that, you could quickly add that and then hit print. So labels show up so it labels every stud that is in the drawing. It puts dashed lines, which are represent the hard side of the stud, so the web of that stud. And this will match the output of the machine. So all your panel assembly guys have to do are run the parts and then kind of lay them out according to this drawing. Put the labels all facing up as long as it's assembled in this orientation, and life is good. You could also then, of course, go ahead and use dimension tools from Rhino to add dimensions. It must be super small right there, but all the annotation tools that are going to be built into the software that we're working on top of will be able to be used from you as a user for this way. So use that a little bit at your own risk. And then the last thing probably that's important to mention is at any time, obviously, you're going to need to save your project for today and kind of go home, work on it tomorrow. When you hit save on your model, all this data is saved inside of that Rhino model. So you don't have to manage a secondary file type or anything like that. All of that really gets managed in kind of appended to a Rhino model. So that's really exciting for us to be able to show you that. And we hope that you enjoyed this overview. We look forward to you kind of experimenting, playing with StudFinder, figuring out how to use it in your workflows. We look forward to kind of hearing feedback, developing requests as they come in from our users. So if you do have comments, requests, of course, you can leave them here in the video. If you want a response from us, it's best to go to our community forum. I'll leave a link to that in in the comments below as well. So please join that. Feel free to comment, feature requests, ask for demos, things of that nature there. Otherwise, until we get on the next video, happy exploring StudFinder and Rhino. And I look forward to diving deeper into certain aspects of Rhino and StudFinder in future videos. So stay tuned.